All right, so let's continue our programming, but before we do that, your homework is due on Friday, and there's this large file that you need to read in and somehow do. And one of the key things in here, so do you remember the text file with temperatures that we worked on in class? Okay. So that text file had first line that said, oh, what's in the columns, and then it had 4 columns and about 48 entries altogether, so it had like 12 by 4. Okay. Now this is actually the same thing, just bigger. All right. So this is a well log, actually just a portion of a well log. Okay. And the way well logs work, they have an entry every foot or so, okay, that is corresponding to a measurement that was done during the logging part. Now, that measurement typically averages something about that foot of rock, something like porosity. Okay? And all of those measurements are then put together into a file that actually looks like this. This is called LAS file. Okay? And the way it works is, first it has something at the very beginning that is basically explaining what it is that you actually have here. So caliper. So caliper is basically measures the width of the well bore. Okay? Or rho, which is basically the porosity, gamma ray measurement, and so forth. Neutron porosity, so there are 2 different porosities. Photoelectric factor, and so forth. So this is basically telling you something just for humans to read, to know what's in the file. And this is the part that we need to ignore. So you will see in the problem, homework problem, it will tell you that you need to read in all of those lines, okay, and just discard them. And there's a bit 20 something of them, so count them up. Okay, so that's the first thing. After that, so there is quite a number of entries, and the problem why it looks messy is that they don't fit all in one row. Okay, so one row continues. This is the depth in feet. So 5300 over 5,000 feet. Okay, and then there's this caliper in inches, 8.4 inches. That's the width of the hole. Okay. And it keeps going. So basically this is the 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. And then it winds into a next row, 13, 14, 15. Okay? Count them up by hand once again. But then there is next line. Okay? So it's just that I don't have screen that is wide enough, but if I did, it would all line up. You see? So if it's wide enough to fit them all, it's just one large matrix. Now you will do exactly the same procedure as we did in class. You will read in all of those numbers, you will figure out how many columns you have, and then reshape the numbers to get what you need. Does that make sense? So again, it's everything we did in class, just with larger number of rows, larger number of columns, larger number of numbers. Welcome to petroleum engineering, and this is going on. I think we have only about 200 feet or so. What's the largest depth in this Ningyu? Do you know? Let's go to the end of the file, which might take a moment. So again, this is a text file, so I'm opening it in text edit, notepad, whatever it is that you have on your computer that is text file. I think it goes to 5,500, right? So this is only over 200 feet. Okay? Now, this is only a portion of a well log that is going all the way. Okay? So you can imagine how many numbers you have if you actually have the actual well log. These type of files, these days you will hear a buzzword, big data. Have you heard that? Big data. Big data means really like a large amount of information. And processing large amount of information Now imagine that you go then to entire basin, like Permian Basin, okay, in Texas, and then you have multiple wells all next to each other. So you have this amount of information for every well in a region that has, for instance, you would typically look into the section, let's say that you want to look into 500 wells and how are they doing. That's what big data is. Okay? It's really just processing large amounts of information and displaying them and finding useful information based on the data you have. Okay? And big data is different for different fields. So petroleum engineering has its big data problems. It's typically processing these well logs and putting them all together. And not only processing well logs at the same time, but also possibly looking into well logs from like 1950s, 1960s, and putting them all together. And technology has changed, so the quality of the data is changing as well. They might be just scanned into files, right? Scanned into images, and then what do? Right? So a lot of this processing is really just this manipulation of the large files. And then, you know, name your coffee company. If it's National Coffee Company, I'm not going to advertise anyone in a particular, but basically if you just wanted to look at the sales of entire company all over the nation, that's big data too. And if you wanted to make a decision based on those sales, same thing, right? So you would look into, but it typically takes domain knowledge. So it typically takes knowing something about petroleum engineering to be able to look at the data. And this is something that I want you to know. So you will be petroleum engineers or geosystems engineers, so you will know about subsurface, you will know what porosity means, okay? You will know what permeability means or what caliper means and all of those measurements. So when you're looking at data, you actually know something about it. Whereas somebody who is better equipped, maybe with a computer science degree, to actually deal with the just large files and manipulating them, has no clue what porosity means. Okay? So this is where you will either have I want you to take that to your advantage. So if you equip yourself with a number of computational classes, you'll be in a better position to process that data and make decision and figure out something than somebody who just has a degree in manipulating data. Okay? Not that that's not valuable, it's very valuable, but you have to know what your value is. And your value will be actually domain knowledge. So if you give yourself computational tools, you can actually go really far. Okay, without further ado, that was my pitch so let us know if you have, actually the data here is every half foot, okay, not even one full. So it's just a large matrix, so you just have to figure out how to reshape it and then plot it. So it should be fun, but it should take a moment. So don't do this Thursday night because you're not going to finish by 9 a.m. Just a suggestion. Okay. Homework comment over. Let's get to some programming. And today I'm actually just going to open MATLAB first. So today we're going to learn first how to direct my programs. This is what I mean by that. Let me open one of the functions that we had, for instance, that area perimeter. So if you have yours, you can open it up. Okay. So here's my area perimeter. And I'm going to actually comment this where I wanted input, and I'm going to put it as an R, back to its original form. So mine is taking N and R and giving area and perimeter. Yours might be taking side length or something and radius and giving area and perimeter back. Either way, it doesn't matter. Now we notice, so we know we can execute this. How do I execute this? So I call the function by name, and then what does the function need? How many input parameters are there? 2. N and R. So I need N, let's put 4, and R, let's put 10. Okay? So what is this number that I got here? Is the area, is the first one. So by default, if I don't do something like this, save this area perimeter into some variables, if I don't do it, then it goes into this default answer, and it's going to get overwritten next time I execute something else. Okay. So if I do this, then area and perimeter are actually recorded. And if I have 4 sides, okay, my perimeter is 80. Now, what if I actually wanted to put in some control? If you provide numbers that are not appropriate, program should say something. Okay, so let's do that. Let's say if, okay, my n number of sides is less than 2, so it's 1 or below, it doesn't make sense. What is a one-sided polygon? Okay. Then I'm gonna print. So I'm gonna use the fprintf format. What does fprintf do? The command for printing or typing things onto your screen. So I'm gonna say, jump in next line and say, this n that you gave does not make sense. Okay. And I'm going to print this n that doesn't make sense. Okay. The font. MATLAB settings. Possibly be a little too big, but let's try 22. This better? So just recall that fprintf, this means I'm expecting an integer. So this number should be formatted as integer, and the rest is just text. This means jump into the next line. So it's just if you typed in enter or return on your computer. And I'm going to add new one. And then I could actually just ask, well, I can do this. Let's execute this, okay? So this is literally following language. So if, and then there's a control statement, okay? If this is true, then this is going to get executed. And I can put as many commands here as I'd like. Else, again, I can put as many commands as I like. So there's a block of commands after if, else, block of commands, end. Okay? And I need to have this, these are so-called relational operators. So I can compare things and make basically often mathematical statements. Something is larger than something else, something is smaller or equal or so forth, and so forth. And I can actually pile them up, so I can actually keep going, and we're going to get into that in a second. So this is a very simple way. I could have done just, I could have also said, okay, now input a better one. Give me n again, something like that. And this will input another value. It will ask the user to input another value. Do you remember this from last time? Input. And in that case, I would actually proceed. I would say end here, and I would proceed with executing with this new value. So this is now a matter of design. How do I want to design my program, and how nice do I want to be to the user of the program? How many little conveniences do I want to put in? I could just let it break if you don't put something. Let's try it out. So I'm going to try to execute with -4. And now it says n -4 does not make sense. Give me n4, and then it proceeds. That's kind of nice. As opposed to just breaking down and then you compute again. Questions? So now I'll go back to the slides. And just elaborate a little on these relational operators. So we have this, if I'm comparing two variables, which is often needed, the result will either be true or false. And true or false is so-called logical data. It's 0, 1, false, true. Okay. So for instance, if A is equal to 2, B is equal to 4, I can come up with a new variable called A is smaller. And that's simply going to test whether this is true. And then it's going to, if it's true, which in this case it is, 2 is less than 4, then it's going to be 1. So try to execute this. So 1 means true. And B is smaller is testing B less than A. That's going to be 0 because 4 is not less than A. So 0 means false. So give this a shot. So most of them operate less than, larger than, the way you would expect them to, but there are little things that are causing problems. Is the way we would write them in math doesn't necessarily translate to computers easily. So for instance, you will have less than or equal to done this way. Okay, so this is just a matter of typing it in a way. So there's less than or equal to, larger than and equal to. Now, this is an interesting one. So this is equal. So if I want to test whether two things are equal, my problem is that equal sign I'm already using for assignment. If I want to say A is equal to 2, in which case I'm defining a variable A that has value 2, this testing whether something is equal is different operations. So if I try to test if A is equal to B, I'm going to assign B to A. I don't want to overwrite, right? So because of that, we have to come up with the new things for testing whether things are equal, and that is equal. Oh, well. Does that make sense? Because equal sign already has a function. It assigns value to another variable, okay? And I don't want to overwrite things while I'm testing them. If you want to see whether something is not equal to, you're going to put tilde sign equals to. So this is not equal. And then I want to pile things together, okay? There's like a logical and, or, and not. So I could just negate a statement, okay? So negating something that is true is false. Negating something that is false is true. Okay? So in a convoluted way, b is smaller would be negated this statement. It's not easily readable, but it's correct. Okay? So I could just put this in parentheses and put a negate side before it. Okay? So you can do things like that. Or you can actually have multiple statements. So you want to say, oh, if A is less than B and B is less than C or something of that sort, then you would put these statements in parentheses and put and or in between them, depending on what makes sense for you. Okay? So you could, so this if else we already have. So now this is where these relational operators are most used. If A is less than 0 or whatever it is, you can say display A is negative and then put an end. So this if statement will typically, if it's true, it's going to have a block of commands. You could just have if block of statements end, or you could have if else end. And you can actually have multiple cases. So this is if you want to have like a big traffic sign switch kind of a thing in your program. If this is true, do this. If this is true, do that. You can build anything you'd like. And you can either do just if, else, end, or you can have else if with like multiple checkpoints of everything that you want to check. So you can just keep going. Okay? So for instance, let's do this. If x is larger than y, then assign c to be this, x squared minus y. Otherwise, this else if is otherwise. If y over x is larger than 0, assign c to be log value of that, end. So what's going to happen? Let's go first row. Who wants to start? Somebody in the first row. One of you guys. Who wants to volunteer? You want to volunteer. What happens if x is equal to -4 and y is equal to -3? Is x larger than or equal to y? No. So this is not going to execute. It's going to keep going. Okay. So is y over x larger than 0? It is. So c is logarithm of that y over x, which is 0.75, 3/4. Okay. Cool. Now somebody from second row. We have 2 candidates. Who wants to volunteer? All right, so if x is equal to 4 and y is equal to 3, what will happen? So this will get computed, and that's it. Then nothing happens here, okay? It just keeps going. So basically my c will be 4 squared, 16 minus 3, 13. All right. Third row. X is equal to -4, y is equal to 3. So this is not true. This is not true. It's just going to end and nothing is happening. In this case, C is not going to get computed at all. And possibly in the rest of the program, that might be a problem. I don't know. I don't know what's in the rest of the program. Okay? All right. So again, you check it with your logic that you're building this, you're designing this if-else, and you can keep going and make it as complicated as you'd like. Don't make it too complicated. All right. So nice thing is actually to put a warning if nothing happens. There's a catch-all. So else in this case would be a catch-all and say, warning, either x and y are both negative or x is less than y, by the way, and print them out. Okay. So this is a good sort of practice so that you don't have these things that it silently doesn't execute, something that you thought it should, and just moves on, and then you're missing it later. Yes? So here you could use display. Yes, good job. Yeah. So here it's really, I technically mostly use fprintf. I don't want to think. I just add because all display does is really adds here the next line, and I think the one at the front. So I can do with fprintf everything that I can. But yes, display is nice. It might be the benefit of display is possibly it's in the program. It's cleaner. It's smaller. It's more compact, so it's easier to read. Yeah, it's easier to read. The way my brain works is like I don't want to think, oh, do I use display or not? I just use one and go with it. So different brains work differently. And my brain works differently before coffee and after. All right. So now we need essentially one more tool, and then we're equipped with most of what we need for effective programming of most of the tasks. The biggest benefit of having a computer that it can repeat things over and over. Repeat, 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 and it doesn't get tired. Doesn't depend on having coffee, nothing. Just keeps going, okay? So there are two main different types of loops. One is called a for loop, and another one is a while loop. And again, this is not specific to MATLAB. This is something that generally exists in all of the other programming languages. So as long as you get the hang of the logic of it, you're good. So one of them will basically loop over, so it needs something to count. It needs to count how many times it's going to execute something. Okay? And that expression is right here. So we're going to give it an index that kind of loops over certain numbers, and it's going to be literally a vector of numbers. Okay? And then it's going to execute something that many times. Okay? And it's going to set the index to the first one, execute, then second one, third one, and so forth. Whereas while loop, it's going to actually check whether an expression is true. So this is where we're going to use relational operators. So keep doing something while A is positive, and then when A becomes negative, stop, okay? So this is used when we don't know how many times we want to change something, okay, or do something. And often we will come in not knowing, okay? If the you might want to say like while temperature is larger than 60 degrees, set the air conditioning, otherwise you don't have to, right? So in that case, and you might want to repeat a number of steps there, and in that case you need to evaluate an expression to see whether you should actually do something or not. So let's give it a try. First example is we're going to create ourselves an array, and then we're going to sum up all of its elements. So this is a classical one that is used all over and over. So I'm going to define x as linspace of 1. I'm just going to give myself 100 numbers between 0 and 1. We remember linspace, right? So this is my x. And now I want to sum up all of the elements of x. And I can type things in, but I'm actually going to transfer this x into a new script and work from that script. So now the for loop that loops over all elements of x, let's just print them first. For index, I'm going to give it name. My index will be I, is 1, 2, number of elements in x. So if you remember, this is essentially an array, right? So these are the numbers from 1 to 100, because that's how many elements I have. So this I will just simply assume all of those values one after another. And I'm gonna do something. I'm gonna, for now, print fprintf. I is equal to, and I'm gonna print myself what is I and x of I. And this is gonna be a floating point value. So I is I, x of I. So I'm simply printing out all of these values that I have just created, these x's, and I'm saying I is equal to whatever the current value of I is. This is an integer, therefore I need to put format integer. And then my x of I is some number that is going to get printed, so that's x of I. Does it make sense? So for fprintf, I need to provide format for the numbers. And these three numbers, I, x of I, are given here to be printed. Let's just execute this. So I'm going to save this as loop exercise. So let's do run. Whoa. Okay. So when I execute, all of them are printed. So here's 81, I is 81, x of I is this. Yeah? Maybe I need to define a smaller array. Let's do this once again with 10. That's plenty. I'm going to clear. Okay. And I'm going to execute loop exercise, this time by simply typing this in. There we go. Is loop exercise a function or a script? Is it a script? Why not? Why isn't it a function? It doesn't start as a function, and it doesn't take input parameters, right? So I didn't define it. Cool. So now let's compute the sum of all of these. The way to do that is you have to set sum to 0, so some number. I'm going to call it S. This will store sum of all elements. And here I'm going to simply update this sum as previous value of sum and current value of x of I. So as I'm going through them, as I'm looping through all of the elements, I'm going to add x of I to it. So I want to sum up. I need to initialize it. I need to set it to something. I need to start from something, right? And then I'm going to keep adding to it. Now, I could have started from x of 1 and then use all of the other numbers. That works too. Okay. And then at the end, I'm going to print that up. Sum of all S is S. And I'm going to give that a level with the formatting. We're practicing fprintf today as much as we are practicing loops. And it's important. It's important to... So now let's execute this. So sum of all is 5. That's interesting. Well, yeah, that makes sense. Never mind. I created a regular array. So it's important to initialize, otherwise what is the computer going to start from? You can't just start adding numbers out of the blue. So this is called initializing to 0. Now that we're at it, how would we compute product of all numbers here? Take a moment to modify it, and I'll ask you to upload that exercise too. So modify your loop exercise to also compute the product of all numbers. So as you're going through the loop, keep multiplying. I'm going to play with the display a little. This is the difference. Thank you. This is the difference. So my computer had it optimized for my computer, not for display. I was like, my font size hasn't been a problem so far. Now I know. Okay, MATLAB preference, and now I can go back to 18. All right. Yeah, it definitely looks better. All right. What is that? I don't know. Let's try. Ah! That was that NUMBER. So that's probably going to interpret it as some sort of like Junkin derivation of that. We just get one. No, initialize. Yeah, one of them is 0. So the product is also 0. So let's change it. That is product. You could have been smarty pants and just say, I mean, I don't need to compute, it's a 0. Because the first number in X array is 0, so product will be 0. So let's change that 1 to 2. So products are always initialized to 1, otherwise they will be 0. And then P I'm going to multiply, and product Okay, so let's run. So now I have product and sum. Mm-hmm.
This is line space and then change to 1, 2, and 10?
Yeah, something non-zero numbers. So numbers between 1 and 2 and 10. You can see that they're between 1 and 2, and they're equally spaced to numbers. Mm-hmm. You can put it to anything else. This is just an example. Everybody got this? Do I need to show my program? Now there was an interesting case that happened over there, and you will have little bugs that you type in, and one thing that can happen is infinite loop. The loop can just keep going. Okay? If you don't, it doesn't have a proper end. In that case, hit Control D. Mm-hmm. Just kills it. Now, sometimes, and I've been in those cases, where I had to completely shut down MATLAB or even my computer. So it can get bad, but the worst that you'd crash is the program. You can reopen it again. Now, another little thing about loops is this array could be anything. This array could go and just this vector of numbers is just a vector of numbers. Any vector of numbers you design is fine. So it can really be something like from 0 to pi over 15 to pi and display sign of y. Okay. It could be something like, let's try this out. It could be something like for, so array of strings, so words, and words are apple, orange, and kiwi. Anybody wants to name an exotic fruit? Dragon fruit. I presume that's a dash or something. Okay. Okay. I'm gonna display that word. Let's try if this works. I can figure out now where my command line is. Oh, wow, hi. All right. It actually went, so this is, it went literally, not word by word, but it went letter by letter, okay? Apple, orange, kiwi, and so forth, okay? So it can be anything, you just have to design it a little better. We can maybe leave it at apple and make it simpler. Okay? It's an array, it works. It doesn't make sense, but it works. And finally, we can also do two-dimensional arrays, and we will do quite a bit with them. But I can nest loops one within the other. So if my head, how am I gonna do a random matrix of numbers, let's say 4 by 5? How do I create a matrix like that? Anyone? Rand of 4, 5. Now let's print those numbers. This is a matrix, so I will actually have to go for every row, okay? For every row, I, and then for every column J. And now I can do something. So now I can do something with A of ij. So this is called a nested loop. And I have to have a nested loop to go over two-dimensional array, especially if I want to go into in the order that this array is set up. So let's actually print those numbers. So I'm gonna say display and say row. Oh no, I need fprintf. Row I, and then I'm gonna add numbers. You can, by the way, run only this section. Here there's a run section. So I highlighted this section and I'm gonna run it. Whoa. I have an invalid statement in here. This one, yes it does. And if you notice, I wasn't paying attention, but there was a red line underneath here. And that's MATLAB telling you, by the way, you have a problem here. And it says invalid syntax, possibly parentheses missing. Not possibly, certainly. Okay.
You can have more than
Whoa.
4 and
And the problem here in my formatting is that I did not. First, I printed these as, I did not leave spaces. So just printed everything together. Let's leave some space. What was the question?
you can have more than 1 4 and script.
Oh yeah, you can keep going. And this is what allows you to access a two-dimensional array properly. So let me just run this section. Whoa. My calendar says you have a next meeting. Guess what? Okay. And now it's like row 1, and these are the numbers. Okay, row 2, row 3, and row 4. I could have done now anything. This is just printing them. I could have added them to a product, to do whatever other transformation I wanted to. It doesn't really matter. The point is that this is how we access all of them. Okay? That's a nested loop. All right. Please, this loop exercise, finish it up quickly, and I'm going to create a Canvas assignment, so that's going to be your quiz. Great.
You want the nested loop or the loop exercise?
This entire script loop exercise that you created. All right.